Alright, welcome back to binary search. Now, when we talk about binary search and compare it with the linear search, right? One of the question is which one is faster, right? It's not really obvious. There are plus and minuses, right? The linear search seems to be slower because we have to go through all the elements in the array, right? So if we find it early, yeah, we can stop searching. But if we don't find it early, we just continue searching, right? Until we find the values, right? Now, this makes it really slow, right? Because if we have 1 million elements, basically we have to go through 1 million elements, right? To find our exact the exact number that we're looking for, right? So the worst case will be 1 million steps until we find the thing that we are looking for, right? But in binary search is supposed to be faster, right? And the reason it's faster is because in every round you have your search list, right? And we're going to look at how this is being done, right? But the assumption being made here is that the items or the elements are already sorted, right? Or ordered in such a way, right, that comparisons can be very easy, right? So let's look at this algorithm here, right? So we have some assumption here, the assumption that the elements is already sorted. So if we're looking for and these are the elements that we have, and we're looking for the number 6, right? So what we'll do is that we'll go through this number 1 2 3 4, right? And what we have is 6, and we're trying to search for 6. But we look at this algorithm, it goes from 1 2 3, and then it reaches 4, right? And then if you look at the number that we're looking for is 6, and 6 is not either bigger than it's basically bigger than 4 and smaller than 6. So we'll start with 4, right? And we stop our searching there, and we continue on the left side, right? So we keep searching, and if we find a number, the number 7 here, and we find out that 7 is bigger than 6, and we make a reverse search there, right? So the algorithm is such a way that we have the time that we are looking for every each search cycle, right? So binary search are a little bit more complex, right? So we would have a prototype binary search here. The same thing, we will look for the number and call a binary search, right? In the binary search, they have something like the left integer, the right integer, and the midpoint integer that we're trying to keep track, right? So in this algorithm, if the left one is smaller than the right, then we choose a midpoint in between the left and right, so, and we keep on searching with that algorithm idea in mind, right? Okay, so this is another two array example that is being used, right? So ignore about the homework in class from the slides, because this used to be there because of the normal semester, and we don't really have normal semesters these days. So please take a look and try to understand the code. Remember, don't forget to declare your array, right? And when you're trying to reference the array, make sure you don't go out of bound. That means you define it as 20 array, but you're trying to access array number 21, for example, right? So you're gonna have a lot of problem, right? So make sure you don't make sure you initialize the array before you start using it, and the counter loop is large enough or equal to the number of rows and columns, right, that we're trying to loop through. So okay, that's it for this chapter on arrays and multidimensional arrays, right? So we'll continue again in next chapter of this class, right? Thank you very much.